In this video, we're going to review how to decompose partial fractions. And we want to know how to do this so that we have another strategy to help us integrate complex integrands. So if there had been an integral here, we would try to think about doing a u substitution, but if we did our u substitution, we would probably let u be the denominator, and then that would mean the derivative of u would be 2x minus 2 dx. And I don't see this piece in the numerator. So a u substitution isn't readily going to work here. That really only works when the derivative is already inside the problem. So one strategy we try to deal with is to decompose partial fractions. And that's essentially the idea of unadding these fractions, saying what were the two fractions that we added together to get this more complex, larger fraction. Okay, so I'm just going to review and detail our strategy for decomposing this into the sum of two partial fractions. In this example, we're going to decompose a rational expression, which is a proper fraction. And by proper, that means the numerator is a smaller degree than the denominator, which is cubic. We have squared in the top, cubic in the bottom. In order for us to use this strategy or technique, we need the denominator to be as linear factors, and in this case, they are unique linear factors. So it may not initially be factored. You may need to develop these linear factors on your own. And by linear, each factor is to the first power. They don't necessarily have to be unique. If you had a repeated factor, say if we put a square on that x plus 3, we have a different strategy for dealing with that as well. Okay, so here we have unique linear factors. So what I want to do with this expression, x squared plus 4x plus 1, over each of these unique linear factors, is we are going to set that equal to a over the first linear factor, x minus 1, plus b over the second one, x plus 1, plus c over x plus 3. So our goal here is to determine what this a, b, and c value are. And once we know that, we'll have three smaller fractions, and these will all be easy for us to integrate. If I put an integral in front of this and say I had the integral of 2 over x plus 1, that's very easy for me to integrate with a u substitution. So as I said, this is our goal, and we need to use this entire equation we've developed to determine what a, b, and c are. The way we're going to do this is we're going to multiply both sides of the equation. I tried to abbreviate that, looks weird, of the equation by the LCD. And the LCD is just going to be the product of these factors. That's going to cause that to cancel. So I'm going to write this all out, what I would look like, or what it would look like if I was multiplying by the LCD. And I've got to write a little small because this is going to be a large expression, x minus 1, x plus 1, x plus 3. So I'm going to multiply this guy by x minus 1, x plus 1, x plus 3. And then we'll do that for the next term, a over x minus 1. We'll multiply that by x minus 1, x plus 1, x plus 3. Again, with our third term, we've got plus b over x plus 1. That again gets multiplied by our LCD, x minus 1, x plus 1, x plus 3. plus c over x plus 3 times x minus 1, x plus 1, x plus 3. So what this does, and I know this is all jumbly on the screen, but it causes my denominators to go away. On the left side, that denominator should always completely cancel. And then on the right side, I'm going to cancel some pieces, the x minus 1 in the a factor, x plus 1 in the b factor, and x plus 3 in the c factor. So once I do that canceling, that leaves me with x squared plus 4x plus 1, don't need that parenthesis, equals a times x plus 1, x plus 3, plus b times x minus 1, x plus 3, plus c times x minus 1, x plus 1. So now this is all written on one line. It's a large polynomial. And we are going to use systems of equations to help us solve for the a, b, and c values. That's our goal, because once we know what a, b, and c are, again, we're going to plug them in, and that's going to be our sum of n partial fractions, in this case, 3 partial fractions. So I'm going to slide this back down. And at this point, we're going to FOIL each of these, because we see we have a squared term, a linear term, and a constant term. And we need to have an a associated with the squared, linear, and constant, a b associated with a squared, linear, and constant, as well as a c associated with a squared or quadratic, linear, and then constant. So if I FOIL each of those pairs, got x squared plus 4x plus 1 equals a, this is x squared plus 4x plus 3, plus b, x squared plus 2x minus 3, and plus c, that would be x squared. I have 0x, I'm going to write that in as a placeholder, and then minus 1. So looking at my x squared term, I have 1 x squared. And how many x squareds do I have? I have ax squareds plus bx squareds plus cx squareds. So I have a plus b plus c x squared. Okay, I have 4 x's being my linear term. How many x's do I have looking at the right side of my equation? I have 4ax plus 2bx plus 0cx. So I have 4a plus 2b plus 0c for my x terms. And we'll do this one more time with our constants. I have 1 equals, how many constants do I have? 3a minus 3b minus 1c. 3a minus 3b minus 1c, and I don't need to write that 1 value there. I can just say c. So I've set this up as a system of equations. This allows me to get rid of the x squared on either side and get rid of the x on either side. I can write this as 1 equals a plus b plus c. I have 4 equals 4a plus 2b. I do not need to write plus 0c. And then I have 1 equals 3a minus 3b minus c. So setting up this system of equations This allows me to solve for A, B, and C. And of course, you can do this by hand, finding that reduced row form using the substitution or elimination methods. But you can also do it with your calculator using a matrix. Now, I know you guys can all solve this system using substitution and elimination methods. I'm going to talk you through how to use your calculator. Of course, I can't pull the calculator into this screen where I'm working. If you don't know how to use your calculator to solve matrices or to use a matrix to solve a system of equations, please email me and I can forward you a video. But I'm going to talk you through it and talk you through the buttons that I push. So right now we are zoned in on this system of equations. You'll notice everything's organized. We have our constants on one side. We have our A's lined up, our B's lined up, and our C's lined up. And when we relate this to a matrix, we're only going to be using the coefficients. So I'm going to look at my coefficients for A, B, and C, and I'm going to list those all organized. My coefficients of A, I have 1, 4, and 3. I've got 1, 4, 3. My coefficients of B, I have 1, 2, and negative 3. 1, 2, negative 3. And then, of course, for my C's, I have positive 1, 0, and negative 1. Now, we write this as what we call an augmented matrix. So I put this bar to represent where my equal signs would be. And then I'll put my coefficients of the constants on the right side of that line. So I have 1, 4, and 1. So this is my augmented matrix. My matrix has 3 horizontal rows and 4 vertical columns. Columns hold up buildings, they're vertical. And when we put this into the calculator, we have to identify our matrix. We always identify it as row by column. I always think of RC cola. So in this case, R by C is going to be, we have a 3 by 4 matrix, 3 rows and 4 columns. So if you want to enter your matrix into the calculator, you're going to press the second button and then X to the negative 1. You'll notice above that it says matrix. So that gets you into the matrix section of your calculator. You're going to want to arrow over twice to where you see the word edit, and then you will scroll down. There are multiple matrices that you see there. You can obviously just choose the first one. You're going to edit. We're going to say this first matrix that we see is 1, and it's got those braces around it, and it says A. Okay, so we want to edit that matrix. So at that point, you'll hit enter. Once you hit enter, it brings up a blank matrix on the screen. The standard size, if you have not edited your matrix, is going to be 1 by 1. This matrix that we are dealing with is, of course, 3 by 4. So I'm going to enter my size. What I'll end up with on my calculator screen, I've got matrix A, and I need 3, the X is already there for times, 3 by 4. So that's going to change the space that you have to enter your matrix values. You are going to want to enter, and it's going to go horizontally across row by row. You're going to enter 1, 1, 1, 1, 4, 2, 0, 4, 3, negative 3, negative 1, and 1. And you want to scroll through using your arrows, make sure all of those values are correct. Because if you type the wrong numbers in the calculator, of course, it's not going to give you the correct answer. So once you're done and you're sure you've typed that all in correctly, all of your numbers, and it gives you, just so you know, it gives you like separate braces that look like this. Okay. And the fourth values might scroll off the screen. You'll have to arrow over to the side to find those. So type all of that in. Once you've got it in, you can hit second and then the quit option or the mode button. That's going to get you out of that screen. And if you go back in and you do second matrix, and that takes you to the main matrix screen, if you just hit enter on the first matrix you see, that's going to bring that up on your calculator screen. So hit enter once to put it on the screen, and then hit enter a second time. That will show you what the matrix looks like that you typed in, all in one concise space. So once you go back into matrix, and then you hit enter, enter, because you're dealing with matrix A. You bring matrix A on the screen and hit enter. It's going to bring you a concise matrix. It won't have this bar in it. All right, and that's going to let you choose your entry and make sure it's correct. Now, at this point, once you know your matrix is correct, you're going to go back into your matrix. You're going to hit second, and then X -1, which gets you to that matrix screen. Previously, we edited. Now you're going to arrow over once. You're going to choose edit. If you scroll down, once you're editing, scroll down to essentially your 12th option. It'll say B, RREF. You want to hit enter to choose that command and put RREF on the calculator screen. That's essentially reduced row echelon form. So once you have that on your calculator screen, then you can click second, go back into your matrix menu, second matrix, and choose the matrix that you want. In this case, we're all likely dealing with matrix A, so you're just going to click A and hit enter. So what it looks like on our calculator screen is RREF. I wrote 3 R's, oh my goodness, RREF. It opens a parenthesis and you have in there matrix A. If you hit enter at this point, it's going to find our reduced row echelon form. So basically, the calculator is doing all of that linear algebra where we multiply and add these linear equations together to determine this A, B, and C value. So once you've done that, the calculator is going to display on the screen 1, 0, 0, 0.75, 0, 1, 0, 0.5, and 0, 0, 1, negative 0.25. And, we have decimal numbers here. It's easy for us currently to know what these decimal values mean, or per se, how to interpret these. And by that, I mean, we know that this is 3/4, 1/2, and -1/4. But you can always just hit the math and turn this entire matrix, our previous answer, math second answer, into a fraction. So what we know is this is the same as 1, 0, 0, 0, 1, 0, 0, 0, 1. I've got 3/4, 1/2, and -1/4 as my answers. So if we think about interpreting this matrix as an equation, what it means is I have 1A, 1B, and 1C. A is equal to 3/4, B is equal to 1/2, and C is equal to -1/4. In linear algebra, this is called the identity matrix, and that's what we always reduce down to. So at this point, we know that A is 3/4, B is 1/2, and C is -1/4. So now I'm going to go back to what we originally wrote, the very first step. We had x squared plus 4x plus 1 over the factors x minus 1, x plus 3, well, we actually had plus 1 first, and x plus 3. And we want to make sure we're writing exactly the same way. I have a over x minus 1 plus b over x plus 1, and then plus c over x plus 3. And since we've determined what my a, being 3/4, b, being 1/2, and c, being -1/4, what those values are, I can now write my original proper fraction rational expression as, I'm going to have 3/4, or 3/4 times x minus 1. We'll have plus 1/2 x plus 1, and then minus 1/4 x plus 3. So this is my decomposition of partial fractions. And because I have done that, now these 3 terms are much easier for me to integrate. So I hope that explains to you, what we're doing when we decompose partial fractions. I know I kind of took it the long way to talk about it, but I'm assuming that some of you may not have seen this before, even though you already should have entering my Calculus 2 class. And then we talked a little bit about the matrices and how we can use our calculator to quickly solve a system of equations. And again, if you didn't learn that in your previous algebra class, I know I couldn't pull the calculator into the screen where I was working, but email me and I'll send you a video that details how to use your calculator to solve a system of equations, to put it into a matrix, and then find that reduced row echelon form.